In this lesson, we are going to work with the distributive property. In particular, we are going to see how we can use the distributive property to rewrite an expression. That is, we'll be able to change the way it looks to give us a different format. And then we'll also see how we can use the distributive property to calculate prices a little bit more easily, basically give you a use for it. Now, before we start looking at the distributive property, there are a couple things that you need to know. You have to know how to add and subtract. You have to know how to multiply and divide. There is a type of problem in math, and there are two different ways that you can go about getting your answer. This lesson with the distributive property is to show you both methods of getting the answer, and also to show you that you can pick and choose the easier way to do it. In particular, the distributive property will let you change the order of operations so that we can create or destroy parentheses and it won't change the answer. Obviously, we need to see how that works. The distributive property lets us change problems like these. According to the order of operations with these set of parentheses, we are supposed to do the parentheses first. 4 plus 6 would equal 10. And so we have 3 times 10, which gives us an answer of 30. That's one way to get the ultimate answer. However, we can observe if we take the second approach, 3 times 4 and 3 times 6, 3 times 4 would equal 12. 3 times 6 is 18, and taking 12 plus 18, that also equals 30. So this gives us then two different ways of getting the answer. The distributive property is all about saying this beginning piece, where there is parentheses, is actually the same thing as this part, where there are no parentheses. And so this lesson is about how do we convert back and forth between the two different formats. Since both ways are going to give you the answer of 30, you can pick and choose which way you want to do it. We'll also note this other example is using subtraction. It doesn't matter if it's adding or subtracting inside the parentheses, the distributive property will work. So, use the distributive property to rewrite it. Pay attention to the directions here. They do not say evaluate. The directions do not say get an answer. They say to rewrite the expression. If you go through and crunch the numbers and give me a number answer of 39, you're wrong because you did not do what the directions asked. In order to rewrite it, we're going to observe, you see the 3 on the outside? The outside number is going to get multiplied with each piece. When we rewrite it, we can take the 3 and multiply by that 9. So we'll just rewrite it 3 times 9. This 3 also has to be multiplied by the second component, plus 3 times 4. We are done. The directions did not ask us to evaluate. They did not ask us for a number answer. All we were asked to do is rewrite, and we've done that. We are finished. There's nothing else we need to do. And as I mentioned, this works with subtraction also. It doesn't matter that they're subtracting here. We can still take the outside number of 7, multiply by the first part, 7 times 10, 7 times 3, and we're done. We have rewritten it. However, we also can use the distributive property to work backwards. These problems are about working backward. In particular, you notice that we do not have the parentheses. In order to rewrite it, we're going to change it back into a format like these beginning ones here. In order to do that, we have to recognize the outside number. Previously, we had the 7 for this outside number, and we'll notice that the 7 was written down twice. In this one, we can recognize the 6 is in both complete pieces. The number that's in both parts, that's the piece that gets factored out. That's your outside number. Recognizing that both pieces have the 6 allows us to say the 6 is put on the outside, and then what got left behind.
8 plus 7.
We're done. We were not asked to get a number answer. The directions asked us only to rewrite, so that's all we need to do. Again, it works with subtraction also. What's the outside number going to be? What can we factor out? Because they both have the 12, that's the part that gets factored out. And then the other pieces, 9 subtract 2. After we factor out the 12, 9 minus 2 is what got left behind. We're done. Moreover, it doesn't matter how many pieces you have inside the parentheses. For this example, there are 3 numbers written on the inside of the parentheses. That doesn't change the distributive property. Our outside number will be multiplied by every single piece. 5 multiplied by 2, we'll write out, plus 5 multiplied by 5, plus 5 multiplied by 3, keeping all 3 chunks. The outside number is multiplied across every single piece on the inside, all of them.
Can we go back?
All right, now let's check our directions here. Use the distributive property to rewrite the expression. Basically, they're saying here is a visual model. Write this out based on a visual model. In order to do that, it's based on the area. Do you notice that this is 1 high and 3 tall? The area here is 3 times 1. Over on this part, we have a width of 4, a height of 3, and so that area is 3 times 4. Over on the left-hand side, we can see that they've taken these 2 rectangles and smushed them together. In particular, here is the 3 by 1, the original small one. This piece is right here. And then the larger one here is just right next to it. Thus, what we're observing, this bottom length, the whole thing is 1 plus 4. The height was 3. All we're doing is writing up the equation that looks like the distributive property, and we're basing it off of these pictures. You'll notice if we multiply it across, 3 times 1 is this piece here. 3 times 4 is that piece there. We're simply trying to create this equation so that it looks like we're writing out the distributive property, and we're using these pictures as a guideline to help us do that. And finally, how could you use this stuff to calculate some prices? This type of problem is really great if you're going to have a bunch of people buying the same kind of thing. For instance, let's say you go to a football game, and at the football game, you've got 3 people who want to buy hot dogs. And at the football game, you've got those 3 people who all want to buy a pop. Well, if we're buying 3 hot dogs and we are buying 3 sodas, we could do this 2 different ways. One way of doing it is to take 3 times $1.25, get the price of the hot dogs. Then we would have to add 3 times 75 cents to get the sodas. This is one valid way to get the answer. You can do it that way. This is also the harder way. Instead of thinking of it as 3 hot dogs individual and 3 sodas individual, we could instead say, I could buy a hot dog and a pop. How much is $1.25 plus 75 cents? That's just $2. We're then buying 3 pairs. So 3 times 2 would give us our answer then of $6. And I'll bet you would agree that doing this stuff in the blue, adding $1.25 and 75 cents, adding $1.25 with 75 cents is easier than going through and multiplying 3 times $1.25. It's easier than multiplying 3 times 75 cents and then adding them together to get the same answer of $6. Both ways will work. You can do the yellow, you can do the blue. They're both correct, they're both valid. It's just about you picking the easier method. If you recognize the distributive property, you can use it and get the answer more easily. That's it.